Very good morning. Today we have the lecture number 5 on radar and TV engineering. This subject is related to the radar and TV. Everyone know about the radar. From the previous lecture, we have already discussed the basic things of radar. What is the meaning of radar? What is the full form of radar? So, radar stands for radio detection and ranging. Today's topic of radar. In this, we will discuss the applications and the frequencies of radar. What are the different applications? What are the different frequencies? And where we can use radar in our daily life. The objectives of this lecture is to learn the radar fundamentals, operating frequencies, and applications. After watching this video, student will able to understand the basic frequencies and the basic different band of frequencies and the different applications of the radar, where that is applicable and where cannot we use the radars and we use the sonars. So student will understand the concept of the frequencies and the applications in the terms of the frequency spectrums as well as corresponding their applications. Next objective is to understand the basic concept of the different types of radars for the surveillance and the tracking. In this, student will understand the concept of types of the radars and their application for the surveillance and the tracking. How they use in the different surveillance and the tracking systems. Next, we have the contents of this video lecture. That is in the first we will discuss the basic introduction of the radar operation frequencies and applications, and then we will discuss the radar frequencies. What are the frequencies which used in our radar systems, and they will how they the frequency changes in the different radars. In the next section, we will also discuss the applications of the radar, how the radar is work in the different application and for the different applications. These are the textbooks. So student will understand the basic fundamental of the radars as well as the application and the frequency spectrum of the radars. They will also understand the concept of the radars by the book by Introduction to the Radar System, that is the Merrill Sconnick Tata McGraw-Hill. That is the special Indian edition for the Indian students, and this is the very good book for the understanding of the basic fundamental of the radar. This is published by the Tata McGraw-Hill in 2007, and this is the second edition. You can also buy the next edition, which is available in the market or online. Some reference books which you also see in the reference section. That is the first is the Introduction to the Radar System. That is the Merrill Sconnick third edition by Tata McGraw-Hill 2001. And next is our Radar Principles Technology Application, Baron Ede Person Education by 2004. Next book is the Principles of the Modern Radar. That is Basic Principles, Mark A. Richards, James A. Sher-William A. Hole, RSD 2013. Radar Handbook by M.I. Sconnick, that is published by the Tata McGraw-Hill again. And fifth reference book is the Understanding the Radar Systems by the Simon Kinsley and the Sean King scientific publication McGraw-Hill. These reference books all is the different book, and it produced the different concept of the radar in the base radar to the modern type of the radars. So you are suggested to buy a introduction to the radar system, that is the Skolnick or best book for to understand the radar system. After learning of this video lecture or watch this video lecture, student will understand the concept of radar frequencies. They will very well know about the radar frequencies. They will understand the different frequencies for the different radars and with their applications. What are their application in the field of environment or day-to-day life of the human beings? And this radar is very important system through which we can find any object at the far distance or any environment. This is the very much good application nowadays. In the case of the pandemic or the corona, you just design a drone. So this device is very much good to find the density area or the effective area. Now we have the introduction about the radar technology or radar system. Again, radar is a contradiction of the word radio detection and the ranging. Means radar is a device or a system which detect the target or object or enemy. If you want to use in the military application, it is applicable to detect the enemy. And ranging of the system means it also find the range of the target. It is a primarily a detection tool. The source of that detection mechanism is radio waves. Means it is detected the enemy or target by the mechanism of the radio waves. Radio waves is everyone know the radio waves work from the 20 kilohertz to 20 megahertz or beyond this. All waves spectrum is known as the radio waves. So student will very well know they about the radio waves, and they know the spectrum of radio waves, from where to where the radio waves are divided. So microwave range is also in the radio wave fields, and this is the spectrum of radio waves. Because our radar system is work on the high frequencies always. Is work on microwave range or beyond the microwave range. So this spectrum is known as radio waves. It comes into the electromagnetic spectrum. Everyone know the electromagnetic spectrum. Radar is an electromagnetic system for the detection and the location of the objects. It operates by the transmitting a particular type of waveform, a pulse modulated sine wave, for example, and detects the nature of the echo signal. Means it operates by the transmitting a particular type of the waveform. Our system will transmit the pulses, that will be the transmitting pulses. That pulse is generated by the high frequency magnetrons, and this magnetron is the microwave oscillators, which is generating the high frequency pulses. These pulses are modulated sine waves by some carrier signal, and these are transmitted by transceiver antenna and detects the nature of the echo signal. So this is the recall of the radar, or this is the basic fundamental of the radar, which we have already discussed in the previous lectures. So this is again revised here. Now we have come to the frequencies. What is the frequency? Everyone knows the frequencies. Frequency is the a cycle which is repeated again and again with respect to the time, or the motion of wave with respect to the time. So the frequency is inversely proportional to the time, and in the case of the radar, we are going to discuss the basic frequencies of the radar. What are the different frequencies which we have used in the radar, and how they are divided for different radars. So here you will understand the basic frequencies of, or basic definition of frequencies or spectrum. So in the radar frequencies, we generally use radio wave band or radio wave frequencies. So radio wave spectrum is applicable for all type of the radar applications. The conventional radars are operated at the frequencies extending from conventional radars are operated at the frequencies extending from about 220 megahertz to 35 megahertz. This is the frequency spectrum for conventional radars. A spread of more than 7 octaves. So the lower range of the frequency is the 220 megahertz, and upper range of the frequency is 35 megahertz for the case of our radar. These are the not necessarily the limits, since the radar can be and have been operated at the frequencies outside the either end of this range. These are not necessarily the limits, since the radar can be and have been operated at the frequency outside either end of this range. So this is the a bare limit through which radar can be operated. But beyond the 35 gigahertz, we can also design the radars, and below 220 megahertz, we can also design the radars. Nowadays, our radar system is always work on the high frequency, because all devices are working in the electronics and communication system at the very high frequencies, because we know that the when frequency is increasing, so our system modeling or system design is, or component or instrument size is reduced. So we are going at the high frequency of the radar designing. The place of radar frequencies in the electromagnetic spectrum is shown in the figure below. In the electromagnetic spectrum, we have defined the particular frequency band for radar applications. These are the radio wave bands or radio wave frequencies. Some of the nomenclature employed to the designates the various frequency regions is also shown in the figure. So in the next slide, we have some nomenclature designated for the particular radar applications and the some electromagnetic spectrum for radar applications. This is the figure of electromagnetic spectrum that is comprising the all band for radars that particularly specified for radar frequencies or radar bands. In this figure, we are able to understand the different wavelength, that is the 10 kilometer. It is starting from the 10 kilometers. Next is the 1 kilometer. Second is 100 meters. Then 10 meters. Then 10 centimeters. Then 1 centimeter and 1 millimeters and 0.1 millimeters. So in this case, we are able to understand that wavelength is going to decrease from high to low, as well as the frequency is increasing from low to high when we are moving to the higher bands or higher frequencies. So in the lower case, we have shown that the frequency band, that is the 30 hertz, 300 hertz, 3 kilohertz, 30 kilohertz, 3 kilohertz, 300 kilohertz, 3 megahertz, 30 megahertz, 300 megahertz, 3 gigahertz, 30 gigahertz, 300 gigahertz, and 3000 gigahertz. These are the frequency bands, and you can easily understand from the wavelength and frequency relationship that is the frequency is inversely proportional to the wavelength. So here we are able to understand that the different nomenclature of the frequency band, that is the VLF band, that is very low frequency bands, or in the case of the wavelength, it is known as the meteorometric waves, or it is known as band 4. Second band is the low frequency, that is known as LF in the nomenclature, and it is known as the kilometric waves, and it's also known as band 5. Next band is the medium frequency band. It is known as the hectometric waves in terms of the wavelength, and it is a band 6, or it is also known as a broadcast band. And next is the HF frequency band. It is known the high frequency band in the terms of the frequency, and in case of the wavelength, the decometric waves, band number 7, and it is used in the OTH radars. And from the very low to high frequency, it is known as the video frequencies band. Next band is the very high frequency band, that is our very high frequency band is applicable in the TV also, and it is known as the, in terms of the wavelength, that is the metric waves, and band 8. From this, our radar frequency band will be start, and the different designation is given in the picture. You all understand that concept. Next band of the frequency is the UHF, that is the ultra high frequency band, and it is the decimetric waves, and it is known as band number 9. It comes also in the radar frequency band. After that, we have SHF, that is the super high frequency. Is not named in the frequency is the super high frequency. The full form of the SHF is the super high frequency. And centimetric waves, it is termed as in the wavelength as the centimetric waves, or band number 10. Next is EHF, that is extremely high frequency band, and it is the millimetric waves band, and band number 11, frequency band number 11, and in the wavelength it is known as the millimetric waves. So band 8, band 9, band 10 and band 11 is applicable in the radar frequencies or radar spectrum, and it is known as the radio waves for radar frequencies. The latter designations is the L, S, C, X, Ku and Ka band in the window of microwave region. Last band is the known as the decimillimetry metric waves, that is the band number 12, and it is known as also some millimeter waves. And after that we have infrared band, and so we will discuss in the next slide the radar bands nomenclature. So next we have the different bands for radar. Latter code designation of radar frequencies. In the previous slide, we have already shows that the L, S, C, X, K, U, Ka, these are the frequency band in the microwave region, and this is the denoted by the radar designation nomenclature. So these are the band for radar frequencies and latter code designation of the radar frequencies. In the development of the radar, a letter code such as S, X, L, etc. was employed to designate the radar frequency bands. Although its original purpose was to guard the military secrecy, the designations were maintained probably out of the habit, as well as the need for some convenient short nomenclature. These are the different nomenclature in the terms of the radars. So each band has their own frequency range. Latter code designation of the radar frequency. This use has continued and is now an accepted the practice of radar engineers. Those who are working in the field of the radar, they know the letter designations of different radar frequencies. Because if you are working in the field of the radar engineering and you don't know the letter of designation or the frequency band, so you will not able to design a system for a particular application. The table below lists the radar frequency letter band nomenclature adopted by the IEEE. IEEE stands for Institution for Electrical and Electronics Engineering. These are related to the specific band assigned by the International Telecommunication Union for radar. So these are the specifically assigned band, and which is used in the International Telecommunication Union for the radar. Understand? That is acceptable by ITU for the radar. So these specific band is particularly for only the case of the radar, and this is governed by or accepted by the international bodies. So you learn these frequency band and understand these frequency band very well. For example, although the nominal frequency range for L band is 1000 to the 2000 megahertz, a L band radar is thought of as being confined within the region from 1215 to the 1400 megahertz, since that is the extent of assigned band. So here we have discussed the frequency range for the particularly L designated band for radar, that is the 1000 to the 2000 megahertz. And the L band radar is the being confined within the region of the 1215 to 1400 megahertz, and we can also extend the range as per our applicable or applications. So the L band stands from 1000 to 2000 megahertz. Table 1 shows that the standard radar frequency ladder band nomenclatures, and then we have the nominal frequency range and specific radio location or radar band based on the International Telecommunication Union assignments for the region 2. So band designation, that is the HF. HF stands for the high frequencies, that is 3 to 30 megahertz, and VHF, very high frequencies, that is stand for 30 to 300 megahertz, and for the case of the radar it is 138 to 144 megahertz, and second band is the 216 to 225 megahertz. UHF is the another frequency band, that is the ultra high frequency band, and it works in the range of 300 to 1000 megahertz. For the particular case of the radar in band for ITU, that is the 413 to 450 megahertz, 890 to 942 megahertz. L band is stand for 1000 to 2000 megahertz. We have already discussed it, and 1200 to 15 to 1400 megahertz. S band stand for 2000 to 4000 megahertz, and it works from 2300 to the 2500 megahertz and 2700 to 3700 megahertz. These are the frequency band for the case of the radars, and here nominal frequencies band is also given. So C band is work from nominal frequency, that is the 4000 to the 8000 megahertz, and in the case of the radar bands from the ITU, that is the 5250 to 5925 megahertz. X band work from the 8000 to the 12000 megahertz, and 8500 to the 10680 megahertz is specifically for the radar bands in the by ITU. Next band is the KU band, and these are the band designations. So KU stand for the band that is work from the nominal frequency from the 12 to 18 gigahertz. So 13.4 to the 14 gigahertz, and second band in the KU band is 15.7 to the 17.7, is known as radar ITU band. Next is the K band. K band stands for 18 to 27 gigahertz, and it is work from the 24 to the 24.25 gigahertz. And next nomenclature or next designation band is the Ka band, and it is having the nominal frequency from 27 to the 40 gigahertz, and radar band for the case of the ITU is stand for the 33.4 to 36 gigahertz. Last band which has a very high frequency, that is the 40 to 300 gigahertz, and this is known as the millimeter wave frequency band. and in this band the wavelength is very large, that is the millimeter waves, and the frequency is up to the 300 gigahertz. So this is the all about the frequency of radar and the different frequency bands and the nomenclature of radar governed by our international unit, that is the International Telecommunication Union. So you have learned these frequency band very well to design of radar systems for a particular applications. Now we have the some application of radar, that is the applications in the field of the civilians, militaries, day-to-day lives, and industrial applications, and we have also application in the field of the medical sciences, in the aircrafts. So radar has a very vast application in the field of communication as well as day-to-day life or the human lives. So military use. First application, here we will discuss only the broad field of the radar applications, but radar has no limit. It has a vast application in the field of technology and in the field of the daily lives. Military use. Initial and important use of the user of the radar, that is the military. Military use radar very well, and early warning of the intruding enemy aircrafts and the missiles, tracking hostile targets and providing the location information to the air defense system consisting of tracking radars, controlling the guns and missiles. Next is the battlefield surveillance and the information friend or if navigation of ships, aircrafts, helicopters, etc. Means radars is generally used in the military to find the enemy aircrafts and the missiles of the enemies and target. They are also able to locate the information of the target defense air defense system of the enemies, and they are also able to track the radar controlling guns and missiles, and they are also able to navigate the ships, aircrafts, and the helicopters of our enemy. Next application of radar is the civilian applications, that is the air traffic controller. It is work as air traffic controller or air traffic control system. All airports are equipped with the ATC radars, air traffic radars. Means in the airport we generally use the radars to control the flights traffic for safe landing and takeoff and guiding of aircraft in bad weather and poor visibility conditions. So the second main application of radar is to guide the aircrafts or our flights in the poor condition of the weather as well as the poor visibility condition or unavoidable conditions. So this type of the radars is a communication based radar which is work in the field of the communication at the airports to uh, landing and take off the flights or aircraft safely. So this type of radar is control the air traffics in the field of airports or air traffic control system at the airports. Aircraft navigations. All aircrafts fitted with the weather avoidance radars. These radars give the warning information to the pilots about the storms, snow, perceptions, etc., laying ahead of aircraft's path. So next type of the communication type radar is applicable for aircraft navigation. In the case of the thunderstorm and snow, they are guiding the radar. They are guiding the aircraft in the bad weather or weather avoidance conditions. So this is a weather avoidance radar to control the air traffic control or navigate the aircraft in the air. Radar is used as an altimeter to indicate the height of the aircraft or helicopters. Next application, in the civilian case, the radar is generally used an altimeter to indicate the height of the aircraft or helicopter at the airport. They are able to find the height of or distance from the ground of the radar or the aircraft. They are easily used to find the height or altimeters uh, of aircraft or enemy aircraft or any other type of the object from the ground. So this is the civilian type of the application of the radars. Beyond of this, we are able to use as a latest technology in the drone. Radar is inbuilt in the drone to take the image or at the far distance in the density area or any avoidable area where we human is not able to move or go that type of the area. So drone is the latest application of radar. Next application of the radar is the maritime ships safety and navigations. Radar used to avoid the collision of ships during the poor visibility conditions, storms and cyclones, etc. Guide ships into seaports safely. Means this is applicable to avoid the collision of the ships during the poor visibility conditions, storms, cyclones, etc. And it is also guide the seaports or ships safely in the field of sea where there is the unavoidable condition of the weather. Then there is the storm, thunderstorms, snow and rain. So in this case radar is very much system to navigate the ships or seaports or boats safely. Next application is the meteorological radars used for the weather warning and forecasting. This type of the radar is the day-to-day warning of the weather or forecasting of the weather. It provides the sufficient advance information to the civilian administrations for evacuations of population in the times cyclone, storms, etc. So this type of the meteorological radar will give the meteorological information regarding the meteorological changes in the environment. Next is the types of the radars output displays. A scan type display used for the gunfire control and accurate range informations. B scan that is the used for the airborne and the fire control range and bearing the forward looking. E scan used for altitude measurement, and the PPI type is the already discussed in the previous lecture. Now, a specific type of the radar, that is, first one is the frequency modulated continuous radar. That type of radars used for the altimeters and the missile guidance, and it is generally used to find the height of the object near the airport. It is used in the civilian application in the airports to measure the altimeters of our flights or aircraft, and it is also used to guide the missiles in the air. Pulse Doppler radar, the carrier wave frequency within the pulse is compared with a reference signal to detect the moving target. So pulse Doppler radar is generally applicable to detect the moving target. If anybody or target is moving towards the radar or away from the radar, so the pulse Doppler radar is applicable to measure the or detect the range. Moving target indicator radars, that is the known as the MTI type system radars, and signal compared with the previous return to the enhance the moving target search radars. It is also known as search radar, that is the MTI radar is work as a search radar which search the moving target. Last is the frequency agile system, and it is difficult to jam a specific type of the radars. One is the SAR or ISAR, system absorption resolutions, phase array, that is essentially 360-degree coverage. It covers the 360 view of object. Phase shift and the frequency shift allow the planar array to steer the beam. Also allow for the high and the low power output depending on the requirements. This will allows the high and low power output depending on our requirements. So this is the picture of the radar system. In the case of the controlling the aircraft from the base station or the airport, here we have a parabolic type of the dish antenna which transmit the signals to the environment, and some part of the reflected waves, transmitted wave is reflected to the target or aircraft, and it will return back in the form of echo signal. So some part of the echo signal is received by the parabolic antenna by same transmission antenna, and some wave from the aircraft is reflected to the other direction, that is work as a wasted echoes, and which is known as wasted echo, which is unwanted echo. We are not able to detect that type of the signal. So wanted signal is in the form of the echo is received by the receiver antenna in the form of the duplexer. The switch work between the transmission and reception of the same type of the antenna, then echo signal is further processed in the receiver system. Now we have a one solved problem related to the previous study. A certain radar has the pulse repetition frequency of 1250 pulses per second. What is the maximum unambiguous range MUR is given by? The formula for the maximum unambiguous range is the C upon 2FP, where FP is the pulse repetition frequency and C is the uh, light velocity. It is 3 into 10 to the power 8 meter per second upon 2 into 1250 meters. So 120 into 10 to the power 3 meters, that is the 120 kilometers. Second question, a shipboard radar has 1 microsecond transmitted pulse width. Two small boards in the same direction are separated in the range by 100 meters. Will the radar detect the two boards as the two target? Solution, radar range resolution. The range resolution of a radar is its ability to distinguish the two closely spaced targets along the same line of the sight. The range resolution is a function of the pulse length, where the pulse length is c into tau upon 2. So radar range equation resolution is 3 into 10 to the power 8 into 1 into 10 to the power minus 6 by 2, and we will find the value radar range resolution 150. Since the boards are at 100 meter apart, which is the less than the resolution of the 150 meters, so radar cannot detect the boards as a two separate target. Understand? So this is the multiple choice questions. What device is the located between the magnetron and the mixtures and that prevents the received signals from entering the magnetron? It is a first choice TR box, second ATR box, C RF attenuator, D resonant cavity. So answer is the ATR box, anti transmit receive box. Where is the RF attenuator used in a radar unit? Between the antenna and the receiver, between the magnetron and the receiver, between the magnetron and the AFC section of the receiver, between the AFC section and the klystron. Answer is C. The number of the patterns, variation patterns required for specific characteristics are A3, B4, C2, and D is the 5. The beam width of the antenna pattern measured at the half power point is called half power beam width, full null beam width, none of the mentioned. It is the question of antenna properties. Next question, what radar circuit determines the pulse repetition rate discriminators? Time synchronizer circuit, artificial transmission line, pulse rate indicator circuit. Answer is B. Given the pulse width of the 8 microsecond and a duty cycle of the 8%, determine the pulse repetition time of the radar system. Answer is 100 microseconds. Patch antennas are the antennas of a small size and are made of microstrip lines. Range markers are determined by CRT, magnetron, timer, video amplifier. It is determined by the timer. The characteristics of the magnetron outputs pulse that relates to accurate range measurement is its A. Amplitude, B. Decay time, C. Rise time, and D is duration. So answer is C. Rise time. A circuit to develop the audio frequency circuit voltage in a radar receiver is called the A. Peak detector, B. Crystal mixture, C. Second detector, D. Discriminator. So answer is D. Correct answer is discriminator. So after learning of or watching this type of the video regarding the radar and system, and in this subject today we have discussed the applications and radar frequency band. Here we have also discussed the radar nomenclature of frequency band in the ITU systems, and in this lecture we deeply discuss the type of the radars, what are the function of this type of the radars, and what are their applications. In this lecture we very much discuss the application of radar in the civilian, military, and industrial as well as day-to-day life. So after watching this video, student will understand the frequency concept, frequency bands of the radar, and the different applications of the radar, and the type of radar in very brief. Thank you.